section 1.5 is on solving inequalities. So last in 1.3 we did solving equations. Now we're going to have the inequalities. All right, so it says interval notation is a way of writing the set of all real numbers between 2 and n. Okay, so this is what we're going to use in Algebra 2 all the time, the interval notation. So it says the symbols bracket and bracket are used when we include an endpoint of an interval, so we use bracket. And the symbols parentheses and parentheses are used to exclude an endpoint. So basically, if you have a number line and we have things shaded, right, we're using brackets. So let's say this was 3 to 5, we would write bracket 3 to 5, bracket. And it would say every point between 3 and 5. So what it's representing is this nice shaded area here. So everything filled in. All right, so we're going to draw a number line for each thing. We're going to write the inequality, and then we're going to write an interval notation. The first thing says numbers less than 4. The numbers less than 4, we draw the number line. We put 4 on the number line. And you don't have to put 0, 1, 2, 3, 4. That's only like that piece when you guys like do all the points. Starting at 0. Don't do that. Like just draw 4. And then I give you things like 56, you're going to be like 0, 1, 2, 3, 4, 5, 6, all the way to 56. Do that. All right, so we have 4. We want everything less than 4. So does that mean that I'm going to shade in 4? No, it's going to be open. So we're going to have an open circle. It's not going to be filled in. And we're going to have everything to the left of 4. Okay, so that's the interval notation. So that's the number line. Okay, so our inequality is going to be x, so numbers that are less than 4, like that. So x is less than 4. All right, in our interval notation, we read it like a book. So we go from the left side to the right side. So we want to include every single number from the left to the right. So if I start way off on the left, I'm including like maybe 5 billion, right? I'm including all those numbers on the left. So what we write is negative infinity to 4 and then parentheses. Okay, so it's saying as I go from the left to the right, I'm including everything all the way on the end, all the way up to 4, and then I stop at 4. All right, infinities will always have parentheses on them, and you never equal infinities. So you're never going to have a bracket on infinity. It's important. No brackets on infinity. Kind of like when you guys were little, did you guys always fight with your siblings and be like, oh, I hate you times infinity, and then they'd be like, I hate you times infinity plus 1. Like that's the classic argument. So you never equal. All right, so numbers greater than or equal to -3. So now we have our number line, and we have -3 on our number line, and we want everything greater than or equal to this 10. So since it can be equal to -3, we're going to fill in the circle, and we're going to shade to the right. Greater than. All right, so basically we have x values that are greater than or equal to -3. So x values that are greater than or equal to -3. If you always put the x on the left for your inequality form, so x and then some kind of symbol and then the number, notice how the arrow points the direction that we shaded. So I shaded on the right side and my arrow pointed to the right side. Okay, so you can kind of use that as a little pin to do right. All right, interval notation. So again, read it like a book from left to right. So as I'm going from the left, what is the first value that I'm taking? -3. So we start with -3. And then we go on forever, right? So we're going to go to positive infinity. And then you get some trouble drawing infinity signs right now. You want to draw 8. All right, so what about my symbols? So on the left side, I'm going to have parentheses or bracket. Bracket, because it could be equal to -3. And on the right side, the line. Parentheses, because you can never equal infinity, right? So you're going to do parentheses on all these things. Okay, numbers between 1 and 4. Now this is a little bit vague. I don't like to say between. A lot of times I'll say between 1 and 4, including the endpoints or excluding the endpoints. if we're just saying between, that really means that it doesn't include 1 and 4. That makes sense? Okay, so we're going to have 1, and we're going to have 4, and we're not going to include those things. So we're going to have open circles. And then we're going to have everything in between. All right, so in inequality, it's a little bit harder to write this. This is one where the x is like sandwiched in between. So it's going to be 1 is less than x, but it's less than 4. Okay, so you're kind of breaking it up into two pieces. On the left side, when you have 1 is less than x, that's really saying x is greater than 1. So any number that's greater than 1. And then the other part's saying x is less than 4, so that's saying any number that's less than 4 as well. So interval notation is going to be, if you go from the left to the right, the first number you hit is 1, the last number you hit is 4. So it's every number that's on that. All right, now if I say numbers 1 through 8, these are the ones that I think include the interval. Like if you start at 1 and you go all the way through 8, again, this one's how it'd be filled in. All right, so 1 and then 8. So you're going to have 1 and it's going to be a filled in circle, and it's going to go all the way to 8. All right, so your inequality now would be 1 is less than or equal to x, so that's less than or equal to 8. And your interval notation is going to look like just like the one above, but it's going to have brackets, right? So it's going to be bracket 1, comma 8 bracket. Okay, so we're going to practice it. So we're going to graph each dot on the number line, and we're going to use interval notation to represent them. Okay, so the first one is saying 2 is less than x, which is less than 3. Okay, so that's one where the shading in between the two numbers. So I have 2 and I have 3. So saying your number is bigger than 2, which goes this way, but it's also less than 3, because it's shaded in the middle. All right, so think about your interval notation. Yep, so now you have 22, comma 3, 20. All right, so the next one. So I have -3 to 4. And the endpoints are different on this one. So the -3 is filled in, right? It says -3 is less than or equal to x. So it can be equal. And then to 4, but that one's not filled in because it says x is less than 4. Okay, so this one is similar to number 1, but one of them doesn't have a bracket. So we need to do. All right, now the next one's a challenge, so we haven't actually learned the next one yet. So let's draw it out and see what we have. Okay, so we have x is greater than or equal to 4, or we have less than -2. So this is two pieces. So we can have greater than or equal to 4, or less than -2. So see how it goes off in two directions. So less than -2, or it could also be greater than 2. All right, so we need to write this in interval notation. So here's what we do. We actually write the two pieces. So I'm going to write the piece on the left, and I'm going to write the piece on the right. So if I just talk about this piece over here on the left, okay, what is that going to do? I'll write just that piece. -infinity to -2. And then what? Parentheses, right? Okay, so I'm going to have -infinity to -2, parentheses. And then if I write the part on the right, that's going to be a bracket 4 to infinity. Like that. And then we want to notate that this is all together the solution. So we need both pieces to be the solution. So we use this fancy symbol. It looks like a U, but there's no stem on the U. So it doesn't go like up and then down like that. You know what I'm saying? Like a stem. There's no stem. All right, so it's just a U. We call that U. So it means all of that together is it. Okay, so a union we read it union, it means or. So you have the left piece or you have the right piece. All right. So it says in the above example, we use the word or. You should notice there were two pieces shaded. And we use the symbol U called union for or statements. Okay, so this part you already have a draft, so go ahead and try to see what you have for any application. So you guys go ahead and try these ones. All right, so the first one we should have bracket -4, comma 2. I think I saw all of you guys. All right, now the next one should be bracket -3.5, comma -2 bracket. And then the other piece is union, or not union, it's parentheses 0.5, comma 2.6 parentheses. And then you want both pieces to be your answer, so you're going to have a union in between. All right, let's try the next one. All right, so the next one starts at -1 and it goes to infinity. It's not including -1, so -1, comma infinity. And remember, we never have brackets on infinity. Okay, so that's what we're going to use in Algebra 2 all of the time. So whenever we have something that's shaded, we're going to use it in multiplication. But there are other methods. Okay, so the next one is actually, I would say it's the easiest way to write something, but it looks the most difficult. So it's strange. It's like, it looks really weird, but it's one of the easiest ways to write something. Okay, so it says set builder notation, a notation for a set that uses a rule to describe the properties of the elements of the set. So the line, so this line, like straight up and down line, is read such that. So when you see all of this in braces, it's saying x such that x is greater than 4. In other words, it means a number where it's a number that's greater than 4. So the thing I like about set builder is it's really like open. Like you can write things in multiple ways. In implementation, it was really only one way to write stuff. So set builder, you can write things all different ways. Okay, so when you see the set of numbers 0, 2, 4, 6, and 8, okay, what do you notice about those numbers? What kind of numbers are those? They're even numbers. All right, what about -2, -4, -6? Let's be a little bit more specific. They're even whole numbers. I like that. So they're even whole numbers, right? So that's one way you could write it. You could just say x such that x is an even whole number. You can write it out. So I like it because you can just use it. All right, so another way, you could say x such that x is even, and then x is greater than or equal to 0, right? That works. You could also say something like x such that x is a multiple of 2, so a multiple of 2, and x is greater than or equal to 0. I mean, there's multiple ways you can do this. This makes sense. So I like set builder because there's lots of ways you can write it. You can just write something and probably going to say. But it is confusing because people don't like the braces, they don't like drawing, they don't like the x such that. It's break time, so we're going to take a break. All right, so the next one says write the set of numbers using set builder notation. Okay, so remember the set builder notation is the x such that. All right, so when you look at these numbers, what numbers are these? What did I call? Integers. So basically it's just saying you have a number where that number is an integer, right? So we're going to say x such that x is an integer. That's it. So see how this notation can be pretty simple. You just write it out in words. You just do the x such that. All right, now you could write this really fancy. So later on in math, if you go into like doing math or anything, you can write it out like this. X such that x, and then you do a fancy e. So it looks like this for your e. All right, and then you write this. Okay, what do you think that means? Now, not quite equal, close though. So you guys remember that the z means integer, right? And the little fancy e means it's what? No? Fancy e means it's element of. So x such that x is an element of the integer. So basically it's just one of the integers. Okay, so that's a fancy way of writing that. All right. Next one. All right, so complete the following table. So all real numbers except 1. Roster notation, if you think about this, for those of you that are in sports, when you call off your roster of basketball, right, you're just listing the players. Does this make sense? If you have a roster, it's just a list of the players. So roster notation is just a list of the numbers. So all real numbers except 1, you can't write it in roster notation because you have all real numbers except 1, like I'm saying. So you could have 0.1, 0.01, 0.001, I, 2 root of 7. And you can have all kinds of figures. So you can't list out all the numbers. Does that make sense? Okay, so interval notation. Think about, for interval notation, always think about what it looks like on a number line. So if you have all real numbers except 1, that means that at 1, you can't include it, so we have an open circle there. So we're going to have everything on the left, everything on the right, but we can't include 1. It's a little bit tricky to write in interval notation, but this is 2 pieces. It makes sense how you have 2 pieces there. So we're going to write the piece on the left, and we're going to write the piece on the right. So the piece on the left is going to be negative infinity to 1, parentheses. The piece on the right is going to be 1 to infinity, parentheses. And then we want both to be our answer, so we do a little union sign. So basically, since neither of them had a bracket, you're skipping over the 1. So negative infinity to 1, don't include 1, 1 to infinity. All right, set builder notation. So if you want all real numbers except 1, you just write it out. So you say x such that x can be anything except 1, right? So we're going to say x does not equal 1. That's the shortest way of writing it. So x such that x does not equal 1. So on the next one, we can write it in roster notation. So we're writing 1, 3, 5, 7, blah, blah, blah. Notice we don't have all the elements, but we've written the pattern enough that we can do the pattern. So how would I describe that in words? So 1, 3, 5, 7, 10. Yes, that's perfect. Yes, so all odd natural numbers. All odd natural numbers. All right, you can't write it in interval notation. Think about why you can't write it in interval notation. The interval would look like this. 1 filled in, 3 filled in, 5 filled in. So how would you write that in interval notation? You can't just say 1 to 1 like that with like brackets around it. You don't do that. You don't say 1 to 1. Intervals always represent like a certain distance in the number line. That's why it's called an interval. So it's a certain piece of the number line that's shaded. So you can't do that in interval notation. All right, so set builder notation. So we just say x such that, and you can just write out x is an odd natural number. You can just say that. So x is an odd natural number. Okay, this one's a little bit harder. So it says numbers within 3 units of 2. Okay, you can't write it in roster notation because there's lots of numbers that are within 3 units of 2. So you have 2.1, 2.01, like I was saying before. All right, but we can't do interval notation. So let's start with 2. And if I'm within 3 units, that means I'm going to go right 3, left 3. 1, 2, 3. So I could go all the way to 5, or all the way to, so this is 1, 0, negative 1. Actually. All right, and it says it's within that. So when you guys hear within, do you think it includes any points or no? No, I think it doesn't, right? If it's within 3 units, it's inside that. All right, so we're going to have everything that's within 3 units of 2. So we're going to have an open circle and an open circle. All right, so your interval notation is -1 to 5. Both intensities. Set builder. So you could just write x is within 3 units of 2. You can write that out. And I'm going to write it using maybe like an inequality. So like less than or equal to or something like that. So what's the way I could do that? X such that what? Yeah. Perfect. Okay. So Jamie says x such that -1. Oops, I got a little crazy down there. -1 is less than x, which is less than 5. Okay. So roster or set builder notation is nice because you don't have to write it in a particular way. So you could write it out simple like that, or you could write out numbers within 3 units of 2. So x such that x is a number within 3 units of 2. All right, so number 4, it says rewrite each set in the indicated notation. All right, so A says x such that x is greater than -3 and x is an integer. So write it out in words. So think about x is greater than -3 and x is an integer. Think about what numbers those are first of all. If it's bigger than -3, what's the first number that's an integer that's bigger than -3? -2. So you have -2, you have -1, you have 0, 1, 2. All right, 11 comes. It's a little tricky writing that in words. It'd be real easy to write out roster notation. That would be roster. So this would be the way to write it out in roster. You wouldn't be able to write it out in interval notation because you don't include intervals. So how can I write this out in words? Yeah. Oh, exactly. So all integers greater than, well, maybe I'll write out greater than, this is where it's greater than. So all integers greater than -2. You'd also say all integers greater than or equal to -2. Or you could say all integers starting with -2. Okay, so positive multiples of 10, let's write it in roster notation. So if I have roster notation, that's the one where it's a list. We still use the little braces, but we don't have to do the x such that. So we're just listing all those items. So positive multiples of 10, that means that it has 10, 20, 30, 40. So once you see the pattern, just use that for that. All right, C, all real numbers greater than 2, set builder notation. So set builder is the x such that. I would think of set being x to like such that, and then set x to such that. All right, so we want everything greater than 2. So you can just say x such that x is greater than 2. You don't have to write that it's a real number because when you write that notation, x is greater than 2, you're assuming that it's already real. If you did that extra step and said x such that x is a real number, comma, x greater than 2. All right, and then all even whole numbers in roster notation. So roster is the one where you just have a list, all even whole numbers. So whole numbers start with 0. Is 0 odd or even? Even. It's the kind of even. So you're going to have 0, 2, 4, 6. That's it. All right, that makes sense? All right, next up. So it's kind of a long section. So it started out talking about inequalities, and now we're going to actually talk about solving inequalities. All right, so a statement that compares two expressions by using the symbols, you have less than, greater than, less than or equal to, or greater than or equal to. It's one of those four symbols. All right, hopefully you guys are familiar with this from Algebra 1, but it's probably been a while. All right, so if you're multiplying or dividing inequalities by a positive number, so it says if you multiply or divide both sides of an inequality by the same positive number, the inequality sign stays the same. It stays the same. Okay, so I think it's easiest to see this with numbers. So if I had, I don't know, 5 is less than 15, right? If I divide by 5 on both sides, right, I get 1 is less than 3. That's still true, right? The sign stays the same. The inequality sign, you don't have to change around it. It's still the same. All right, but if you multiply or divide by a negative number, so if I have 5 is less than 15, and I divide by negative 5 on both sides, this becomes negative 1, and this becomes negative 3. Think about negative 1 and negative 3 on your number line. So you guys see negative 3 is less than negative 1. So the sign goes this way. Right? The bigger one, just like alligator, you don't know that, and then just the alligator, bigger one. All right, so give negative 1 is greater than negative 3. All right, so what happened is your sign was less than before, but when you divide or multiply that negative number, you have to flip the sign. I would call this the red flag rule. All right, so it says then the inequality sign changes or flips. Okay, so otherwise you're just solving it just like an equation. If you're adding or subtracting the both sides, keep your inequality sign is the same. But whenever you multiply or divide by a negative number, you have to flip it. Okay. So this one I have 8y plus 6 is less than negative 12y minus 18. So let's subtract the 12y over. So I get negative 4y plus 6 is less than negative 18. Subtract the 6 over. So if I subtract 6, I get negative 24. So negative 4y is less than negative 24. All right, now imagine it's an equation. If it had an equal sign, it's divide by negative 4 on both sides, right? Okay, so if I divide by negative 4, that's where we have our red flag. Draw on the red, so this is black on this side. All right, so you get y is greater than 6. Yeah. Now, on your test, I always say, graph the solution on the number line, write your solution in interval notation. So don't forget that step. If you have y is greater than 6, make sure you do your number line. So we have 6. We have everything greater than 6. So it's parentheses 6, comma, infinity. That's the answer that I want to see. I want to see interval notation. Now I just want to show you some people, so you don't have to write this down, but some people like to avoid the dividing or multiplying by a negative number, and they do it a little bit differently. Okay, so here's how you could also do this problem. So we start back at the beginning. And some people are like, oh, well, I don't want a negative 4y, so I'm going to subtract the 8y to the other side. Does that make sense? That way you're getting a positive 4y. All right, and then add the 18, so you get 24 is less than 4y. And when you divide by 4, now you're dividing by a positive number. So you get 6 is less than y. That's fine. You can do it that way. Just make sure if you have 6 is less than y, you're drawing it correctly on your number line. That's really saying y is greater than 6. I usually rewrite, so see how the bigger side of your inequality is with the y? Like I said, the alligator's mouth part is with the y, but make sure the alligator's mouth is with the y when you rewrite. Okay, so you can do it that way as well, and kind of avoid the flipping. All right, so you guys try number 2. All right, so the first one, so you can subtract the 4a to both sides, or you can subtract the a, just like you just said, right? Well, let's say I subtract the a. so I kind of avoid the flipping. So I'm going to have 9 is greater than or equal to 3a plus 18. Subtract the 18 and you get negative 9 is greater than or equal to 3a. Divide by 3. Oops. Divide by 3, negative 3. And you get negative 3 is greater than or equal to a. All right, so how that's read, if you want to put the a first, it's really a is less than or equal to negative 3. It doesn't matter if you rewrite it. It just kind of helps when you put it on the number line to know your arrow is going to go to the left. So if you have negative 3, you're going to have it filled in, and you're going to go to the left, right? All right, so let's see. So that's going to be negative infinity to negative 3, and then a bracket. So that should be your final answer. Let me do a second. All right, so let's try the next one. All right, so we have negative b is greater than b minus 7 over 2. So this one might cause a little fear in your heart. Oh my gosh, there's a fraction. What do you do? So let's get rid of the fraction. So let's multiply by 2 on both sides. So I'm going to have 2 times negative b is greater than b minus 7. So I just multiplied the 2 to the other side. All right, I don't flip the sign or anything, so it's positive 2. So I get negative 2b is greater than b minus 7. Let's subtract the b over. So I get negative 3b is greater than negative 7. Divide by negative 3. That's where you have your red flag, like, oh my gosh, divided by negative, so I have to flip the sign. So I have b is less than 7/3. So on your number line, put 7/3. And I like to see 7/3. I don't like to see 2 1/3. So I like being proper. So 7/3. It's everything less than that. So you have an open circle. So it's negative infinity to 7/3. All right, now number 4 is the super challenge. All right, so we haven't talked about this. I did put this on one of my homework problems for the first practice. Something like this, where if you have, let me do a simple example down here. Let's say I have an equation like this. If you see a bunch of fractions and you don't want fractions, you can actually get rid of them. Do you guys learn this second algebra one? Okay, so if you want to get rid of fractions, what you do is you multiply through by what's called the least common denominator. So if you were going to get all of the denominators to be the same, what would you change all of your denominators to? Not 8, 6, right? You change them all to 6. Your sense to be a 6, you have 3, you have 6, so you change them all to 6. All right, so we're going to multiply everything through by 6. All right, and I'm just going to multiply that 6 into the entire equation. So when I do that, I'm going to have x plus, and then you have 6 times 1/3. What is 6 times 1/3? That's 2, right? So 6 times 1/3 is 2 equals, and then I have 6 times 5, 6. What's 6 times 5, 6? 5, right? The 6 and 6 reduce down, right? So 5. Or you can think of 30 over 6 is 5. All right, and then all of a sudden you have a super simple equation. X plus 2 equals 5, so that equals 38. Isn't that nice? So we're going to do that on this first one, or on this fourth one. So we're going to multiply through, and we're going to clear the fractions together. So I don't want to have fractions. That's what Caleb's saying. He's saying the common denominator for this one is 8. So he wasn't looking at the example I had. So he said 8. So we're going to multiply through by 8. So I'm going to take that 8 into every single item. Now I'm going to write that in between steps. So I'm going to have 8 times 3m minus 5 over 8. Minus 8 times 4 minus 5m over 4. Notice how I left the negative. I left it on the outside. 8. And it's greater than 8 times 3 minus 2m over 4. Okay, so I'm writing that step where I multiply the 8 into everything. I just want you to see this step. So on the first parentheses, you have that 3m minus 8, or 3m minus 5 over 8. And you multiply that 8. You guys see what happens? And the 8 actually reduce out. On the second parenthesis, you have 8 and you have 4 now. So what happens there? Yep. So they reduce down to 2. So you still have the 2 on top. And then the last one, you have 8 and 4. So again, you're up 2. So what you've simplified it down to is 3m minus 5. You have negative 2 times 4 minus 5m is greater than 2 times 3 minus 2m. So you clear the question. You don't have to do this. You could just get them all to have common denominators and deal with the 8 in the bottom. But I think it does make it a little bit easier. All right, so you have 3m minus 5 minus 8 plus 10m is greater than 6 minus 4. So you got 13m minus 13 is greater than 6 minus 4m. All right, so add the 4m over, so you get 17m. Add the 13 over, so you get greater than 19. So you get m is greater than 19 over 7. So in interval notation, you would have your 19 over 17, and then you have everything bigger than it, so everything on the right. So it's going to be 19 over 17, comma, infinity. That's it. We need to get that one. All right, so number 5, it says Marissa has at most $20.50 to spend at the convenience store. She buys a bag of potato chips and a can of soda for $1.55. If gas at the store costs $2.35 per gallon, how many gallons of gas can Marissa buy for her car to nearest 10 per gallon? Yes, what did you set up? I did 1.5. Yep, I'm going to say it is less than or equal to 20.05. That's fine. So Josh said he had it on the left side. I usually put it on the right side. So she's already buying the bag of potato chips and can of soda for $1.55. That's pretty cheap too. Actually, gas and I can actually in the dollars. It's like $1 something. You guys can. It's like you guys don't drive. You ever notice like none of your friends like drive around? You have to text each other. I don't know. So $1.55 plus $2.35 times the number of gallons of gas. So usually I like to see you defining the variable. So let x equal the number of gallons of gas. And all of that has to be less than or equal to the $20.50. Okay. So we're going to subtract out. So subtract out $1.55. So 235x is less than 1895. All right, so subtract out, or divide by 2.35. Divide by 2.35. And you get x is less than 8.1. Yep. So if you can round to the nearest 10, so about the most you can get is 8.1 gallons, right? That's the most you can get. Oh, it's hard to like stop the gas thing too. Maybe she should try for 8. Probably gonna end up being 8.1. You what? Oh yeah, we can go in. That's too much effort though. I don't want to have to walk into the gas station. You couldn't do that when I was in high school either. We didn't have like these fancy debit cards. I'm old, so you guys are lucky that you guys have these. All right, so the last section is section 1.6. So we aren't going to do that today.